We'll be talking about prosper. Now let's start with the meaning of prosper and what is really used for. Prosper stands for Production and Systems Performance Analysis Model. Now this is a well-performance modeling software that is produced and developed by the petroleum experts. What's the function? It's used to analyze, it's used to design, and is also used to optimize the performance of oil wells, gas wells, and water wells, whether they are flowing naturally or not. Now, Prosper also helps engineers to answer production questions such as how much fluid can this well produce? Now, this is a very important question because you must consider the economic feasibility of producing from any well. What size of choke should I use? Should I use gas lifts or should I pump lifts? Prosper answer many other questions. Now, before I talk more on it, let's appreciate our environment. That's basically what I'm going to be discussing today. We're going to understand our Prosper environment. Now, as you can see, we have a window divided into 6 different blocks. We have the option summary, the first, and then we also have the PVT data, IPR data, and then equipment data, analysis data, and then we have the Prosper 11.5 where we have a summary of the petroleum experts. Now we start with our option summary. Now what is the function? What is the essence of our option summary? Or how do we even initiate it? You can initiate it either by double clicking or by going to the options on a menu bar. You can click and then you go to your options and there you have your options there. If you don't want to use this method, you can go to the option summary, just double click on that block. Now we're already here. This option summary affords us the opportunity to set the environment for our work. It's just like a foundation on which we're going to build our model upon. So then you need to make critical decisions which are based on the type of data you are presented with. The first decision you need to make, you need to decide on whether you're producing oil, whether you're expecting dry and wet gas, or whether what you're expecting is your retrograde condensate. Most times, since the target of most wells or of most drillers is to obtain oil from the well, we go with the oil and water. But if you're expecting dry and wet gas, that means the fluid type you're going to be choosing is a dry and wet gas. So this is just based on the kind of fluid that we have in that specific reservoir. Next, we move on to the method. You need to decide on the method you're going to use to model your reservoir. So you need to decide, are you opting for black oil or for equation of states? Now you're going to choose the method based on the PVT data you have. If the PVT data you have is for ordinary oil and you're just provided with your standard PVT data, then you go ahead with black oil. But if what you have, that's the data that you provided with, requires high accuracy and you're giving detailed compositional data, then you may need to go for your equation of states. What I mean by detailed compositional data is maybe you're modeling a gas condensate or volatile oil well, then you will need to go for equation of state. But most times we stick with our black oil model. Now the next item here is our separator. What type of separator do we choose? Is it the single stage separator or the two-stage separator? Now for the single stage separator, you use it when you have only one separator condition. That is where you have just one pressure condition, temperature condition, or GR condition. Then you go for your two-stage separator when your PVT lab report gives data for multiple separator stages, you have high pressure conditions and you have low pressure conditions. In that case, then you go for your two-stage separator. But in most situations, in my experience, I've come to discover that single-stage separator is the one that is most generally used. And then you hydrate. You want to enable warning or you want to disregard warning. Hydrate is simply gas, and when you have water in your gas, it causes a lot of problem. So you want to, be warned when you're having hydrates. You can enable or you can disable. It depends on your choice. And then the next thing is water viscosity. What kind of correlation do you want to use? I would advise you go with the default correlation. And then the viscosity model. Under the viscosity model, we have the Newtonian fluid and we also have the non-Newtonian fluid. Now, when do you use the Newtonian fluid? In Newtonian fluid, you use it when viscosity remains constant. That is for fluids that have a constant viscosity, irrespective of the shear force that is applied, whether the fluid is turned around, or whatever the fluid goes through, the viscosity still remains constant. Then in that case, the viscosity model that you should choose is the Newtonian fluid. But in a situation where the viscosity changes as a result of shear force applied, then you go to non-Newtonian fluid. But our black oil usually have a constant viscosity, so that is why we go for Newtonian fluid. Now, flow type under well, we have tubing flow or annular flow or both, depending on where you're producing your fluid from. Tubing flow most of the times. And then what type of well do you have? Do you have a producer well, or do you have an injector well, or water injector? You make your choice. Remember, if you're producing, if that well basic purpose is for producing oil or producing whatever, you use your producer well. Would you need to do any artificial lifts? Perhaps the pressure is not enough, then you decide on which method to use. And then the next section here is user information, the company you're modeling for, the field, the location, the well, and all that information that may be required. Under this analysis, of course, you, the modeler, will have your name written there. Under the calculation type, you choose what calculation type do you want to go in for. Are you opting for the pressure only, pressure and temperature on land, off land? So you choose based on the data provided. Are you working offshore or are you working on land? So you choose based on the environment you're working on. So on model, you choose rough estimation. Most of the time I go for rough estimation, though it still depends on the kind of data or the kind of field you're working with. And then we have our range, we have our outputs. Now basically we leave all these unchanged, especially when you are not doing any artificial lifts, and also when you're working with black oil. It's advised you just leave it at default. When you're done, you click done. Boom. You will discover that all the sections, all the blocks are now filled in with what? With data, ready for us to proceed. Now next on the line, we have the PVT data section. Now these are data where you input your data. Now how do we gain access into this PVT data section? You simply do that by double clicking. Once you double click, you'll be allowed to enter your parameters that of course will be provided by the company. We have our solution GOR, we have oil gravity, gas gravity, water salinity. You enter for all those values. If there is any impurity, you enter it. And then if none, you allow it at 0.000%. Then for the correlation, you need not bother with the correlation at this point. we'll have to match data, regress, and choose correlations that best go with the type of oil we're working with. And then when you're done, you simply press done. Yeah, it's showing this because I've not entered any data. I'm not entering any data now. I'm going to start entering data for tomorrow. We're going to be working with a real life example. So I'll just click done, and then I'll cancel. So the next section here is IPR data. You don't. Now this section is actually showing error because right now we are not entering any data. So when we start entering data by tomorrow, you'll see how it works. Now this IPR data helps us to plot our graph. There you will see the AOF, which is the absolute open flow. You'll see the corresponding, you'll see the rates at which it's producing at AOF. That's the highest possible rate a well can produce. Is actually an ideal value. Now after that, we move on to the equipment data. The equipment data here, we have the deviation survey, you have the surface equipment, downhole equipment, geothermal gradients. We are going to be imputing our data based on the value provided. And next, we have the analysis summary. Here we are going to be carrying out sensitization. We're going to be sensitizing some of the parameters like the reservoir pressure, the tubing sizes. We're going to be sensitizing different parameters, even the water cuts, to see the value that will give us the highest flow. And then the last column there, which is just giving us a detail of Prosper. So I believe that with this introduction, you now understand what our Prosper is used for. You can now tell which block is used for what. So join me tomorrow as I'll be going into details, working side by side with an example to explain how Prosper can be used. Thank you very much.